Hello there! In today's video, I'll talk a bit about general inventory system design in video games, and also how I designed and implemented my very own inventory system. But before we get into it, I just have to tell you how happy I am to finally get back to programming in Unreal after like 2 months of my player character modeling in Blender. It's mind-boggling to me that Blender can implement full-body inverse kinematics without writing a single line of code, while Unreal requires you to use their own weird visual scripting for control rigs. Anyway, rant over, let's get to our main topic of the day. So, what is an inventory system and what function does it have in a video game? Well, it's just a system that lets you store items and it gives you some kind of interface to access the storage, right? Wrong. An inventory system is pretty much a database, and it requires a lot of backend functionality and operations that the player will probably never see or notice them happening. So, let's take a few steps back and talk about each of these items one by one. Simply storing items is simple enough. All you need to do is create some sort of class or data structure that will hold all the critical information about each item. For example, if you have an item parent class and all items are children of that class, you could create a dictionary where item class names are the key and the amount held by the player is the value. That's a very simplistic system, and it falls apart instantly when you have to add items that cannot be stacked, or if you want to control maximum stack capacity, since the map cannot contain 2 keys which points to the same class. And by the way, if you didn't understand the last few sentences, then I'm afraid you might need to brush up on your object-oriented programming knowledge, or just use a marketplace plugin for inventory. As I said at the start of the video, inventory systems require a lot of backend, and a newbie programmer might be unable to create a robust system without some serious practice. Luckily, inventory systems for single-player indie games are usually quite simple. If your game has microtransactions or paid DLCs, then you probably need some kind of outside database, and then expose it to your game through an API, so that the player cannot manipulate the amounts in an expected manner using cheat engine or other tools which mess with local memory. In this video, I'll make a system that's 100% local, but if you'd like me to do a tutorial on a system with microtransactions, then all you need to do is pay me $1,000 to unlock that DLC, you greedy little bitch. Anyway, let's get to item number 2. The interface. This step is actually very straightforward. Like all user interfaces, the goal of this step is to expose the backend functionality to the player in a controlled manner. As a developer, I can call a function to add 100 apples to the inventory anytime I want, but the player shouldn't have that option. The most difficult thing about interface is the artistic design of the inventory, and maybe some drag and drop features. I'm not sure how it works in Unity, but in Unreal listing the items is very simple, since you can create a widget for an item button and then populate the inventory widget with child item widgets. But we'll get to that in the implementation part of this video. Now the next step is probably the most important one. Setting inventory limitations is a crucial part of the design process, and you shouldn't move forward with the task until you complete this step. This is the part where you need to imagine how your system will work and list as many details about it as possible. To be honest, you should start thinking about this before you even get started with your inventory system, but I put it as step number 3, since your plan should be complete at this point and you'll need to adhere to it moving forward. Let's try to do a very simple analysis of 2 inventory systems to help you understand what some limitations and rules might be. First, let's talk about Skyrim. The inventory is a list of all items the player owns, where all items can be stacked. However, items which have different names and sell values are counted as different items, so an enchanted iron sword is different from a regular iron sword. What limits the player is the carry weight, and when you cross the threshold value, your character walks very slowly and the game becomes very inconvenient to play. So in practice you can carry as many different items as you want, as long as you're under the weight limit. You can also sort items by different categories, especially if you use some mods. Magic spells are also in the inventory, and once you own a magic spell you cannot acquire it a second time, so they can be treated as unstackable objects, except when you acquire a new one, it doesn't create a new stack, it simply ignores the item acquisition. That implementation is a very good system for a game where going into the dungeon you don't know if you'll find weapons, souls gems or cheese. As long as you keep the weight under control, you can pocket pretty much anything. Now, on to our second example, Minecraft. This time you have an inventory with a limited number of slots. In Skyrim, each inventory item was just that, an item. But here, each inventory item is actually a container, which can either house an item or be empty. That means you can organize your equipment by yourself by moving slots around, which is impossible to do in Skyrim. However, there are some additional rules to how the items are stored. Some items can be stacked, some cannot, and the stack size can be controlled. So for example, most building blocks have a stack size of 64, while eggs or snowballs have a stack size of 16. In this system, when an unstackable item is acquired, the inventory system puts it in the first empty slot. If there are no empty slots, you cannot get any new items. So while Skyrim allows you to carry a large variety of items as long as they are in low quantities, Minecraft actually incentivizes you to carry a large quantity of a few items to keep the slots open. Of course, these were very broad descriptions of these systems, but you can probably already see that there is a lot of things to consider when designing the rules of your system. There are also games where you have different types of inventories, like in Dark Souls, where the player inventory has a different stack limit from the warehouse inventory. Once you come up with all these rules and limitations, you might need to go back to storage definition, but most of these rules can be enforced in the next two steps, so let's keep going. The next step is basic database operations, so adding new items and removing or updating existing ones. While they may sound easy to implement, these functionalities need to be very robust and oftentimes modular, so you can call them from varying sources with varying effect. For example, when adding a new item, you must consider if the item is stackable, and if so, where in the memory is the stack located. And if you plan on allowing the player to pick up multiple items at once, so for example they can get 10 health potions from single pickup, then you need to ensure that adding these new items will adhere to the stacking rules. But the add item function is more or less always the same, if you can implement the rule compliance correctly. However, removing items happens in a variety of conditions. You can use the item, discard it, drop it, or transfer it to another storage, and all of these operations require you to run the removal function. So it's up to you if you'd rather create multiple functions, or maybe some kind of a driver variable, which will change which parts of the code are run, or maybe keep the removal function itself simple, and just surround it with a bunch of other code in the events that call it. The next step, sorting and ordering, is the second part of adding a basic database functionality to our system. This step highly depends on what kind of inventory you're working on. If you're creating a list type of inventory like in Skyrim, then all you need is to create a simple sorting algorithm, such as a bubble sort, quick sort or anything you like. Now for slot-based inventories, this part can be quite tricky, especially if your game uses items that take up multiple slots. You can also give your player the option to call an automatic sorting function, like in Grim Dawn or Resident Evil series. There are also games like Minecraft, which simply don't implement any kind of sorting. But no matter the inventory type, there is no trickier step than the last one, making the inventory user-proof. Now you might be wondering, why make a system user-proof? Shouldn't the game be as accessible as possible? You see, a user or a player is a bit like a politician. In theory, their goals align with yours, but in practice you learn to ask them a simple question. How will you try to fuck me? Players will implement a whole range of glitches and exploits in order to manipulate your inventory systems in ways that are clearly not intended. For example, in Hearts of Iron you could get infinite resources by pulling out of some high-stakes trades you created before. On the other hand, in Minecraft there was an item duplication exploit which required the player to crash the server in a controlled manner by causing an overflow of data in one chunk. Of course, it's impossible for a small indie team to predict all the ways in which players will try to mess with their game. Personally, I don't mind leaving some exploits alone. If someone really needs infinite items to have fun in my game, then they are welcome to enjoy the game any way they want. However, if a mistake in your item adding function allows the player to duplicate stacks by simply trying to combine two full stacks together, then you've got a problem. Studies have shown that players will usually choose the most powerful option available to them, even if it decreases the challenge and the fun of the game. You don't really need studies to notice that. Just look at all the assholes running around with Moonveil or Rivers of Blood in Elden Ring PvP. So in other words, exploits need to be difficult and cumbersome to pull off, otherwise lots of players might get bored with your game quickly, just because they got overpowered way too fast and way too easily. There's a maxim that says that those who can't do, teach. So after this long lecture you just got, let me show you that I can actually implement the system myself. But before we begin, just note that this is more of a design walkthrough than a technical tutorial. However, in the video description you'll find a link to a playlist that's a great technical tutorial on inventory systems. My system is more complex than the one in the playlist, but the tutorial is a great starting point. Also, I was recording footage as I was developing the system, so don't be surprised if some things look different between shots. Now, let's get right into it. First, I'll lay out the rules of my system. My system will be slot-based, with most items being stackable, with a few unstackable ones. The stack sizes will vary between items. The player will be able to organize the stack themselves. There are container objects which have their own inventory that can only be accessed while interacting with the objects. You can transfer items to and from these containers. Right now it's more or less a Minecraft clone, but there are also some differences. You can purchase extensions for both player and container object inventory to get more slots. There's a household inventory, which can only be accessed through specific objects and in specific areas. This inventory is also slot-based and stack sizes still apply, however this storage has infinite slot capacity, so the player can dump all their items into it. I might give household storage some different organization options, such as filtering by category, if I feel like it needs that option after some playtesting. I might also add some kind of maximum slot capacity, for example 1000 slots, because I have a strange feeling that someone would try to split every stack they have into tiny one-item slots to artificially increase the number of available slots in order to fuck with the game or to crash it. And the last rule is that the system has to be easy, quick and intuitive to use with a mouse cursor. First I created a blueprint component that I can attach to any actor, and the component itself contains all of the inventory backend logic. That way, once I create a container object, I can simply attach the inventory component to it instead of programming the whole thing from scratch. Then I created a class for an item and a few child classes, one for a stackable apple item and one for an unstackable knife item. Each item has editable item info variable and an editable amount variable. The item info allows me to control the stack size and check if the item is stackable, and the amount controls how much is picked up when the player overlaps with the collision box. As for our inventory, I created some simple functions, such as checking if a slot is empty, finding the first empty slot, or finding a slot with the same item class as the pickup. At that point, I added an add item function. At first I made it very simple, so that it always puts the pickup item in the first slot, just to test if the slot system is working at all. Then I added a simple inventory interface. I'll come back to styling it once I figure out a good color palette for my game. The UI has the player's inventory on the right and household or container inventory on the left. Each panel has an empty grid component, which is automatically populated with slots anytime the inventory is opened. Each slot is a child widget, which means that it can run its own code. The inventory widget itself has very little logic. It simply handles slot population, closing the inventory, hiding the container and household panels if they aren't in use, and throwing away items, but more on that last one later. Things like running inventory functions or slot updates are run by the slots themselves. At that point it was time to make the add item function a bit more complex and turn a nice, simple and readable function into a spaghetti demon from hell. Basically, when there is an available slot, it checks if the item is stackable. If not, the item is placed in the first empty slot available, and if the item is stackable, then the system finds its first available stack and adds the item on top of it. If you're wondering why the function is in a loop, it's because instead of adding the entire amount all at once, it adds items one by one. That way I can ensure the rules of stackability for items. Of course, the entire loop is processed in a fraction of a second, so it's pretty good performance-wise. But I also added the break so that once the system has no free slots, it stops trying to add new items. I ran a few checks of adding a single item, multiple items and a few stacks at once, and it all worked perfectly. At that point we have the read and write database operations, so let's add the delete operation. I decided to make a very simple removal function, which simply deletes a specified number of items from a stack and clears the stack if none are left. The complexity of removals that I mentioned before is actually handled in other places, after or before they call the removal function. And now that we have all our basic stuff ready, let's get into the fun part. It's time to make it so that the player's actions in the interface start calling the functions we prepared in our backend. Not only that, the way the player interacts with the interface must be simple and intuitive, otherwise the quality of our game will suffer. So the first thing to do is to actually let the player select a stack. Unreal Engine has a pretty decent drag and drop system, but I'm not a fan of drag and drop inventories. They are alright in hack and slashes where you rarely interact with inventory, but imagine dragging and dropping in a game which requires a lot of inventory management like Minecraft. So, speaking of Minecraft, I chose to steal their way of doing it and implemented it in Unreal. It's a system that's nearly identical to drag and drop, except you don't have to drag anything. You just click once to pick up an item and click once more to do something with it, and until you do, it will follow your mouse cursor. By the way, I haven't found a tutorial on that kind of inventory anywhere, so if you'd like a technical tutorial, let me know in the comments, and I'll happily do it since I'm an attention whore. Then I implemented some mouse functionality. Alright, a lot of mouse functionality. The simplest one is that when you hover over a slot it changes color, but only if the slot is not empty, unless you're dragging something. Then every slot changes color when you hover over it. It's a tiny difference, but in my opinion these tiny differences can really make a game feel more inviting and interactive. And now, the mouse click. This is where the magic happens. The script runs like 100 checks to find out the conditions of the click, like was it a single click or a double click, was shift down, or did you press left or right mouse button, or was the drag widget active. So, if you press an empty slot, nothing happens. Shocking, right? Anyway, while dragging is inactive, a single left click selects the slot and initiates dragging. A left double click uses the item if it's usable. A single right click takes one item from the stack, and a double right click takes half of the stack at once. Once the drag is active, both single and double right click take one more item from the stack onto the drag widget, unless your drag payload is already at stack size limit. Of course, you can only pick up the item if it's the same class as the one in your payload. A left click adds the drag payload to the selected slot. It might sound simple, but the add item operation has as many different behaviors as all right-click functions together. It checks if the item is one of the same class, and if not, it swaps slot item with drag item. Same thing happens if either of the two slots is at stack capacity. If the slots have the same class, but the target slot is under stack capacity, then items are added to it and removed from drag payload. The most difficult part of the process was definitely planning it, since you need to know most of the checks you'll pass into branch nodes before you even start placing them down. But here's the system working with just the player inventory. At that point, I added the option to throw stuff away. Sadly, Unreal Engine doesn't have an event that's triggered when you click outside of the widget, so I went with a crafty little trick here, where I created a component and made it invisible. When you click on it with drag active, it simply deletes the drag, thus throwing away the item. Then I created two simple objects, one for container inventory and one for household inventory. I started the game, interacted with them, and when everything worked exactly as it should, it felt better than having an orgasm. I wasn't sure if I was a genius, my hard work was paying off, or maybe the universe finally took pity on me, but I was incredibly happy that I didn't have to go back to the inventory backend to mess with the add item function. But yeah, here it is. A lot of the stuff is a placeholder, such as the container actors and the general interface look, but we've got a fully functional, fairly intuitive, and a robust inventory system in place. Right now, the only challenge, other than replacing the placeholder assets, is making the system also available to use on a gamepad. However, gamepad accessibility is not exactly a riveting subject for a video, so I'll do it sometime in the background. I might also add some kind of a hotbar at some point, but only if I feel like the game needs it during playtests. Anyway, I hope you enjoyed the video, and feel free to leave a comment and subscribe. And that's all for today. See ya!